everyone, I am Vedant and I am going to discuss about Poisson distribution. In this video, we will see about what is Poisson distribution, its advantages and its limitations. After that, we will see the R language code by which we can plot Poisson distribution graphs and curves. So starting on with Poisson distribution. What is Poisson distribution? Poisson distribution, it is a limiting case of polynomial distribution. The PMF of Poisson distribution is defined as P of x equal to e power minus lambda into lambda power x divided by x factorial. This is the equation of Poisson distribution. So you guys are familiar with PMF. PMF stands for probability mass function, also called as probability function or frequency function, which characterizes the distribution of discrete random variables. So next, coming on with the advantages of Poisson distribution. Poisson distribution overcomes the problem that are arising in normal mode. As the minimum value of Poisson distribution is 0, then there are no negative values. Because of the lowest value in Poisson distribution is 0, hence it overcomes the problem that arises in normal distribution. Coming on with the limitations of Poisson distribution, there is only, as I said, it's the only limiting case of binomial distribution. As the number of travel, that is n, increases, then the disturbance increases in this Poisson distribution. After a certain point, the values remain constant in Poisson distribution. That is the only its limitation. Moving on with the R code. So you guys are already familiar with R language. I have explained in my previous videos. If you are not, then a link is in the description. You can follow through that link and watch the earlier video. So probability distribution of random variables for different lambda. Lambda means stands for mu in that equation. We simply look what happens to the Poisson ratio curve when we alter the values of lambda. So we are going to use some keywords that are in our code. PAR stands for graphical parameters. MPRO, this is used for splitting several planes. I am using 4 graphs, so I will split the screen into 4 types. Later you can see that. DPOISSION, this stands for Poisson density. This is a short keyword in our language. Now coming on with the code, we will demonstrate our code in an online platform, that is rdrr.io. You can directly Google it as R code and you will reach this website. PAR, that stands for parity, and MPRO, as I said earlier, that is using for splitting the screens. We will demonstrate 2 plus 2, that is totally 4 curves. When we paste the code, that stands for plot. Plot is the keyword which is used for plotting of graph. DPOISSION for Poisson density, and lambda value we are giving earlier as 2. When we run this code, we'll obtain the graphical representation of it. You can see the graphical representation of Poisson distribution. It is seen like this. So let's see what happens when we alter these values. We'll take values initially phi, and we'll take values of it as like 100 and 10, and we'll take its value as 20. The values are lambda equal to 2, seen already, lambda equal to 5, lambda equal to 100 and 20. These all 4 graphs will be seen now. When we run this code, you can see this graph represents the code for second line, that is lambda equal to 5. When lambda equal to 5, such graph is seen. For lambda equal to 110, for greater values it is seen like this, and for a smaller value, that is you can see for lambda equal to 20, value is seen as like this. So the nature of graph remains same, but the values alters, and as we move in goes on increasing the value, the discreting characters of graph goes on decreasing. This is a clear demonstration of Poisson distribution using this graphical method. Hope you guys have understood it. Thank you for watching this.